Hi guys, welcome to our channel of Sciences and Mathematics. In this channel we deal with a large aspect of mathematics, physical and biological sciences. So in that case we engage ourselves in dealing with some aspects of theory, trying to explain the concepts and developing the problem solving skills for mathematics and especially physical sciences in chemistry and physics. So in that case, today we are going to deal with a class of organic compounds by the name ethers. And ethers, in that case, we're going to do an introductory topic that is pertaining to nomenclature. So without further ado, thank you and welcome. So as we have said, we are going to discuss about the nomenclature of ethers. That one is physical feedback. This is actually ethers. Physical. This is different kind of, so that is physical. So for that case, as we have said, we are going to discuss about the naming of ethers. Naming of ethers is very important for us because as we go ahead and try to encounter different class of organic compounds, for us to identify a particular functional group and be in a position to give it IUPAC name or the scientific name that is supposed to be used for maybe a community of scientists and other educators, it is important for us as maybe learners to know how these particular names are derived. So ethers are a class of organic compounds that result from the reaction of two alcohols. Of course, that's under the condition of conc sulfuric acid that is used to ensure that there's removal of a water molecule from the combination of these two alcohols. So for that case, I'll just give a general representation for that particular kind of reaction so that we can be able to see how the ethers are generated. So in that case, let's give a R or H as the first alcohol, whereby R denotes a radical, can be N, member maybe methane, ethane, butane, etc. So in that case, if it's a methoxide, a methanol as a first member, ethanol, etc. So we have, that's the first alcohol, and then we have a different one that is R prime for another alcohol, which are reacting under the condition of a conc sulfuric acid, that is conc sulfuric acid. Now this one will result in the formation of an ether by removing a water molecule from these two alcohols. So we shall have a product that contain R or R prime, which is the first and second one respectively, plus a water molecule. So this is a general reaction for the formation of ethers, as we have said, that ethers are, remember, a class of organic compounds, and one way of course of forming ethers is by the reaction of two alcohols and a conc sulfuric acid to form an ether and a water molecule, and that is water. So this is a general representation for that. So we shall go ahead and try to look at one of the examples, specific examples of a reaction that can lead to the formation of an ether by using of two simple alcohol groups. So let's look at this example. We have our first alcohol, CH2OH, plus another one that is a C. For this I just the same H, CH3, this will be 2. And then this is conc sulfuric acid. So the product, as we have said, if we try to look at the RH groups, in this case, this is an Al group, a radical for that. The two respective alcohols So we can see that their structure formula is the same, so we shall have that member as methyl. I mean, that is ethyl, that's the second member of the alkane series, so we shall have the name as dimethyl ether. Methyls are two, so we shall have this particular ether, which is CH3, CH2O, CH2, CH3. So in that case, if we try to see at the side of the reactants, and after the arrow on our right side, which we presume, of course, which is a product at this particular point, we shall have that one and a water molecule. So in trying to name this, we can see from what we have already learned is that these functional groups that are being attached to O are the same. They are the second member of the alkane series that we call ethane. So in this case, in naming of ethers for us, we shall take the radicals or the alkoxy functional group as a, of course, as a parent group. So in this case, they are similar. We shall have dimethyl ether. So this compound, okay, let me just take the name here. It's known as dimethyl ether. So two names, dimethyl ether. Now, dimethyl ether is a product that is formed from the reaction of those two particular alcohols. So let's try to see another example of an organic compound, but of course before that, I've already written this name, but let's try to see on how, or the format in which this particular name has been done. So we can see this is dimethyl ether, and I said that for the general case of an ether that has been formed of this particular kind, whereby R is similar to R prime, then we shall take the prefix for that particular function, I mean that parent group, as a di, so it is dimethyl. There are two methyls attached to that functional group there, so we have a dimethyl ether as the name. So in this case, the parent name, which is the alkoxy group OR, is treated as a substituent, which can be either an alkane or another functional group, as we have said. And in ethers, common names, we said that we have IUPAC, and then we have common names. And then in this case, there are some common names which are generally accepted by the naming system, or maybe a community of scientists that they can as well be used besides the IUPAC naming system. And for that case, for this member of organic compounds that we are calling ethers, the names are accepted. For instance, let's look at one of the examples so that they can be able to give us the general format for naming this class of organic compounds. Let's have a member of the ether family that has this particular formula. So this is so as we have said, the alkoxy group is treated as a substituent. So in that case, we shall have this member as a substituent, and then we shall name it as this space might not be the same. I'm thinking of writing. Of course, I hope this one is visible from there. So we shall have methyl 1, 2, 3 butyl ether. So if you try to see those two specific names, there's a characteristic ending by the name ether. So in that case, in naming of the ethers, they always have that characteristic ending ether, but we shall look at an IUPAC naming system. Of course, these are the common names that we're using for this particular compound. Suppose it was a 4-member carbon group at this particular point, CH3, then it will be methyl, that is methyl. Oh, this one was supposed to be propyl for 3 members, so it will be methyl butyl ether. So for a 4-member is methyl butyl ether. For a 3-member, methyl propyl ether, etc. So these are the common names that are usually used for ether groups. And let's try to look at one example of the IUPAC systems that may be used as the names besides the common names that we have mentioned. By looking at this example, we have a CH3, CH2, and then we have a OCH2, CH2, and then CH3. Putting the events to try and separate this so that you can be able to demonstrate well. So we have that particular member of the group. So suppose we had that name member, then let's try to see the common name that will attach to this member of the ether groups. So as we have said, the alkoxide group makes up the substituents, and the group that we are talking about is the OR group. So we shall have this side containing 3 carbons. So from the alkyl series, this is propane, and then this is 1,2-ethoxide. So the name, the common name for that, we shall have ethyl. We shall have the ethyl propyl ether. So ethyl derived from this is ethane, ethyl propyl for the 3-member part of this. We say that this alkoxide group forms the parent name, and then we have this particular section that is forming the rest of the name. So we have ethyl propyl ether with this characteristic ending, as we said. So for IUPAC naming system, we shall use the format that we have been using for other functional groups. So as we said, the alkoxide group will form the substituents. So it is we shall use this designation. As we said, this one will be given as a group, and this one, so it definitely will be attached at point number 1. So we shall have the ethoxide group as 1, ethoxide, so we have this second, propane, as the other name for this particular compound, of course, which you have said, following the systemic rules that we are talking about. So for that case, the common name will be ethyl propyl ether, whereas the IUPAC 1-ethoxide propane for that particular case. So suppose we have another functional group attached to an ethoxide group, then how do we go about the naming? So let's look at an example whereby we have another functional group or a substituent that is attached at a particular point. And we shall look at a similar example as this, but at this point we have a OH group. Just indicate this one as H2. We have a OH group attached at that point. Then in that case, this is the alkoxide group. Of course, which we have said forms which is treated as a substituent. Then the parent name, we shall look it enter this other section of that structure. So if we try to look at this, this is another functional, of course, a functional group that we talked about, which is a OH attached to R, which is this, which is an alcohol. So since it is a 3-carbon member group, we shall have the name propanol for this part of the organic compounds, and this is a 2-carbon member group, the alkoxide, so it is the 10. So we have the substance as ethoxide. So the name of that particular compound we shall look at what point is the carbon group attached from the functional group. So we shall count, this is 1, 2, 3. So it's attached at carbon number 3. So the name will be 3-ethoxide propanol. 3-ethoxide propanol. So that will be the name of that particular compound. So in this case, we have taken consideration for that particular functional group which has been attached to the structure, and then we have followed those rules of treating the alkoxide group as a function, as a substituent, where the rest of that one, of course, forms a parent. Forms the rest of the names with that particular compound. So in that case, let's try to look at perhaps another example. Of that. So generally, this last example that we are supposed to look at also follows the same rules, which of course we have said that the longest chains gives the, which we derive from the Ken series, of course, gives the other name apart from this particular name, which is giving a substituent. This other section gives the other name of that particular compound. So that is same rules which are actually trying to apply here. The rest, in using the IUPAC system, follows the names as other class of organic compounds like the alcohols, etc., as we have mentioned. So in that case, this is the general format for naming ethers, and I hope that when we shall come or encounter other class of organic compounds or specific rules that need to be applied or exceptionals, we'll be in a position to try and mention that. So for today, thank you very much, and welcome as we proceed. I hope that we are still being active on the comment section as we had requested, so that in case of any challenge, we are able to handle it together and maybe assist one another. So for that case, for today, thank you. God bless you. Bye.